Hey class, good afternoon. So let us now come to the second part of the presentation and compressor. So this presentation class gives you the example of the discussion in the first presentation. Okay class, so let us now consider this example. The discharge pressure of a two-stage air compressor is 690 kilopascal and has a suction volume flow rate 0.194 cubic meter per seconds at 100 kilopascal and 22 degrees Celsius. So calculate the heat rejected by the intercooler. So this is class a multiple choice problem. So we have here A 9.23, B 20.56, C is 13.73, and D is 14.23 kilowatts. So that is class the heat rejected. So okay, so we have here class the given. So the discharge pressure is 690 kilopascal. So the suction pressure is 100, and the volume flow rate is 0.194 cubic meter per seconds, and the temperature is 22. Okay, so take note QR is the unknown. Okay, so we have here class the intercooler pressure. So this is the square root of 100 and the discharge pressure 690. So the intercooler pressure class now PX is 262.68 kilopascal. Okay. So getting now the heat rejected. So that is QR equals to MCP delta T. So that is QR equals to 0.23 for the mass multiplied by CP of water is 1, and then the change in temperature. So 22 is now converted to Kelvin, so that is 295. Okay, so the take note class that the in getting the temperature of the intercooler or between the intercooler is Tx over T sub 1 is equals to Px over P sub 2 raised to n minus 1 over n. So this is uh, what class? What kind of uh, equation is this class? So this is under the polytropic compression. Okay, so Px class is the intercooler. Okay, so getting now or substituting the values, getting the temperature of course at the initial condition. So that is Tx 388.74 Kelvin. So and then class substituting now from this equation QR equals to MCP delta T. QR now is 21.5 kilowatt. So what is the answer class? 21.5 kilowatt. So which is not present in the option. So anyway, so we have here 20.56. Okay, so that is letter B. Okay, so next, using now the ideal gas equation, PB equals to MRT. Okay, so we have here class the mass substituted in the previous equation. The computation is this PB equals to MRT. Okay, so where the pressure is 100, the suction pressure, the volume is 0.194 cubic meter per second. M is unknown, and then we have here 0.287, which is the gas constant for air, and then 22 plus 273 is equivalent now to 0.23 kilogram per seconds. Okay. So another example class, we have a single acting compressor operates at 150 RPM with an initial condition of air at 97.9 kilopascal and 27 degrees Celsius and discharges the air at 379 kilopascal into cylinder tank. Okay? So the bore and stroke are 355 mm and 381 mm respectively with a percentage clearance of 5%. If the surrounding air is at 100 kilopascal and 20 degrees Celsius, while the compression expansion process R PB raised to 1.3 raised to constant. So this is the polytropic equation class. So determine the pre-air capacity in cubic meter per second. So again class, this is a multiple choice question. Okay. So let us now proceed to the solution. So we have here the given suction pressure 97.9, discharge pressure 379, T sub 1 is 20, The diameter of the bore is 355 and the length of stroke is 381. Percentage clearance is 5%. The suction pressure. Okay, so this is the outside pressure class. This is not the discharge pressure, but this is the outside condition or the ambient condition. And N is the RPM and N is the polytropic constant. Okay, so getting now the displacement. So that is of course LAN, the length of stroke, area of the bore, and the number of revolution. Okay, so substituting values class, BD now is equals to 0.09343 cubic meter per second. So from the volumetric efficiency equation, so we have here volumetric efficiency equals 1 plus C minus C, P discharge over P suction raised to 1 over N. So substituting values, the polytropic or the volumetric efficiency now is 90.84%. Okay? So again, volumetric efficiency is can also be computed using the volume or the actual volume divided by the piston displacement. Okay, so getting now V sub 1 or the pre-air capacity, that is 0.086 cubic meter per second. So getting now the relation of the pressure and the volume, and getting volume at 2, that is 0.085 cubic meter per second class. Okay, so we have here another example. An industrial plant has 4 cylinder of 386 mm by 740 mm single acting compressor running at 1.5 revolution per second, and it is used to pump air to 1.772 megapascals. Assume that the average air receiver temperature is 30. How long will it take the compressor to fill up the 200 cubic feet air receiver from 827 kilopascal if the volumetric efficiency of the compressor is 65%? Atmospheric air at 100 kilopascal and 20. Okay, so again class, this is multiple choice question. So for letter A, we have here 3.66 minutes, B is 2.66, C is 4.66, and D 5.66 minutes. Okay, so let us now proceed class to the given. Diameter 365 millimeter, length of stroke 740, number of revolution per second is 1.5 or 90 RPM, discharge pressure 1750 kilopascal, temperature 30, so suction pressure rather, so 827. Okay, so this is the compressor the pressure of the tank rather. Okay, so 827. So the volume is 200 cubic feet or cubic, yes, or 5.67 cubic meter. The volumetric efficiency is 65 and atmospheric air at 120. Okay, so getting now the equation, PB equals to MRT. So getting now the mass, it's 53.9 kilograms. Okay, so the for the second condition, okay, so this is at 1750, so the mass is 114.057 kilogram. Okay, the change in mass now equals to the mass, of course, at the tank. Okay, A equals to M2 minus M1, so that is 60.157 kilograms. Okay, so density now equals to mass over volume. So 1.2 the density of air, and then change mass is 60.5. The volume now is 50.13 cubic meter. So this is now the volume added class. Okay, so defining again the volumetric efficiency, and then substitute the value of 0.65. Getting B sub 1 now is equals to 18.4176 cubic meter per minute. Okay, rate of volume entering. Okay, So, solving now for the required time. So, time is equals to volume added divided by the rate of the volume entering. Okay, so that is now 50.13 divided by 18.417 cubic meter per minute. Therefore, the answer now is 2.72 minutes. Okay, 2.72 minutes. So, which is class letter B. Okay, so 2.66. Okay, so 2.72. Thank you very much, class. That's all about the presentation for the second part of the compressor. Okay, thank you very much.